Hello everyone, +2 here. We are doing 2025 Level 3 Differentiation, question 3A and B today. A says, the graph below shows the function y equals f over x. For the function above, find the values of x where f of x is not differentiable. Right, it's typical question. Each year we expect this kind of question. Now, not differentiable. Two conditions. One, jump. So like this from here to when I draw this, I have to lift up my pen and then I can start from there, right? So well, obviously I can't differentiate when x is -6. So that's not differentiable. And then over there, not only it's when x is -2, right? You have to jump. Also, this is a sharp corner. So at a sharp corner, you can't differentiate. So -6 and then -2. And then over here, it's a sharp corner as well, right? And also it is jump, you can't differentiate that corner. So 3. So when x is -6, -2, and 3. All right. Question 2 says, find the values of x where f prime x equals 0. Right. So meaning gradient is 0, right? So that's over here, right? So this line showing the gradient is 0. So I would say x is less than -6, right? And if you see over there, that's a turning point, right? So we have to spot all the turning points. So that's a gradient is 0, and that's another gradient 0. So it's local minimum and local maximum there. So which is when x is less than -6, and when x is -4 and 6, right? That's a gradient is 0. Right, what is the value of limit f of x when x approaches -2? So at -2, from left to right and right to left, so at x is -2, y value goes towards 2, isn't it? So the answer is 2. Okay, that wasn't hard. Question B. A curve has the equation y equals ln x over 2x. Find the coordinates of any stationary points on the curve. So, well, when it comes with stationary points, first of all, turning points. So obviously we have to find y prime, right? To find the turning points. So that's turning points. And second prime to find what? Point of inflection. So they both are called stationary point. All right. So you have to find the y prime and set a equals 0, and second derivative a equals 0. That's what we are gonna do. Right. So first derivative. So I'm gonna say u equals ln x, right? So hence u prime equals 1 over x. I'm gonna write u. And v, denominator is 2x, and v prime is 2. Hence, y prime first derivative is v prime minus uv prime, isn't it? So it's 2 minus 2 ln x over v squared, which is 4x squared equals 0. That means 2 minus 2 ln x equals 0. Hence, ln x must be 1, meaning x must be e, isn't it? Right? Because it says x coordinates, so well, that's done. You know, you don't have to find the y value. So that was turning point. And second, so say this is the first one. So we found first one, and second one here, point of inflection. We have to differentiate first derivative. So this one here. So we set u be 2 minus 2 ln x. Hence u prime is minus 2 over x. Let me explain. So when you differentiate 2, that becomes 0, and minus 2 times ln x. So when you differentiate ln x is 1 over x, so therefore u prime is minus 2 over x, right? And v is 4x squared. Hence v prime is 8x, isn't it? Hence second derivative is v prime, so which is 4x squared times minus 2 over x minus uv prime, which is I'm gonna factorize by 2, so it becomes a 16x 1 minus ln x, isn't it? Over v squared, which is a 16x to the power of 4, right? So when I simplify this, I get minus 8x minus 16x, which is minus 24x plus 16x ln x, right, over 16x to the power of 4. That should be 0, right, to find the point of inflection. So that means minus 24x plus 16x ln x should be 0. That means ln x must be what? 24x over 16x, which turns out so x is gone, 3 over 2, isn't it? So ln x is 3 over 2. That means x is what? E to the power of 3 over 2. So that's when this equation, this curve has a point of inflection, right? So this is the first answer, and this is the second answer. So that is a turning point, and that is the point of inflection. All right, so I'm gonna write number 1 and number 2. All right, I will see you next time. All right, bye.